This is the second Excel VBA game that I've created. This one I've called Catch the Space Invader. This is based around the event mouse click on an ActiveX label. The game is controlled through a loop and a game timer. Adjust the loop and the game timer. You can extend or shorten the game in the iterations. It's quite a quick game to play, and the idea is that the user tries to select the icon with the mouse and the icon keeps moving about. That's really what the game is about. But in the background you get introduced to Excel events. As with the first game that I created, have a look at the code. It's not the best code in the world, but it gets the game done. Improve it however you want. Kind of make it your own game. You might even want to add sort of different speeds or different actions based on the user level. Let's see how we play the game. This is my Catch the Space Invader game. It's kind of a simple game. It's an intro to gaming, part of my intro to gaming series. Now the game has 3 levels: easy, medium or difficult, and each one has a different starting size alien icon. Each game is initiated by the new game button, where you'll get a count-in and then the game will start. So the easy alien is quite large, and every time you click on it, it randomly moves to another place within the game screen. Each time you click on it, your score moves up 1. And I scored 12 points on this go on easy. Now if we go to medium and play again, we get a count-in. And the alien's smaller now. A little bit more trickier to catch. And it's giving my mouse skills a bit of a workout. And I managed to score 8 points on that. Now for difficult. And the icon's even smaller now. This really is giving my mouse skills a bit of a workout. And I managed to score 8 again. Feel quite pleased with that. So that's the game: easy, medium, difficult options, and new game. Now how we built the interface. We set up a grid with column width 2 and row height 15 to give us roughly sort of squares within that grid to work with. In theory, we probably didn't have to make squares, but it just made it easier designing the interface. Next, we're going to set the boundary for the game area, and this is field cells. So we define a color for the field cells. And in this case, it's our alien green. And that will be in rows 5 and rows to rows 37. And columns C to AN. The next thing we do is we put a border around those cells that we've just filled, and we'll make the outside border a green, and that's a predefined green, and the inside of the border is a light green that we define. Next is a merge cell section, and this is where we'll show the user game messages such as the counting 3, 2, 1 and the game over message. We'll call that n counting as a named range. We'll also define the option buttons, their output, and that will also be a named range, and we'll define that as n game level. And you can see here through Name Manager that we have the two defined names. Now we're going to create the game title, and we're just using word art for this. We're going to manipulate word art to fit at the top, and then we'll give it a nice alien glow. Now we'll add our option buttons, and we need 3 of those for easy, medium and difficult. We'll edit the text for each one. And now we're going to set the properties for these option buttons, and we're going to link it to a named range. Only this time I forgot to put the named range in. I just linked it to cell C3, which is a name range n game level. We also set the color of the option box and its border. We're now aligning the shapes. And now we're going to stick them all within a rounded rectangle shape and group them together. And this way it makes them easier to move and manipulate. Each option button is able to be selected even though it's grouped with the shape. Next we're going to create the button, and that again is a rounded rectangle shape. We're going to color that and define its outline. And then we'll add text and format that text. We'll also use this button as the template for our score box, the graphic that shows the score. So we start off with the button and then we adjust it for how we wish the scoreboard to look. Next, we'll copy the title and we'll adjust that for the label for the scoreboard. And we'll reduce its size, change the text and format it. Now we're going to put the game over text in the merged cells and we're going to format those, and this is to give us an idea of the size that we need so that when we need to change the size we know what size. Now we're going to add the alien graphic, and that's an ActiveX label. We're going to call that LBL alien so we can refer to that in the code. Set the height to 30 and the width to 40, and then we're going to add the alien GIF. Now we're going to set the background, and this is another image that we've got online, and we'll tile this image. I wasn't fussed about matching the tiles up. I just really wanted a space image more than anything else, but I could have taken more care and made it a little less obvious that it's tiled. And that is the game interface. Now onto the coding behind the scenes. Now we're going to have a look at the code behind the Catch the Space Invader game. Go to Developer, Visual Basic, and we open the Visual Basic IDE. Now, rather than seeing all the code and all the subroutines in one go, I'm going to select Procedural View only, if I view the Properties window so you can see clearly as well. I've created two modules, so we've got Alien module and we've got Random Move module. And I've prefixed these with MDL so it helps me understand what I'm looking at any one time. Also within the game we have code in sheet 1 which is named Alien, and we have one sub here, and that's for when the user clicks the alien. The other piece of code is in this workbook, and what we do is when the workbook is closed is we ensure that events have been re-enabled. So now if we go back to the main module, which is the alien module, I'll click on Procedural View only. We can see that no procedures are visible, but we have some global variables, and these variables are just for sharing information around the game. Int game level as integer. That's the number, that's the level that the user selects when they select an option. So easy is 1 and difficulty is 3. SHP alien, that's a shape, and that's the label where we have the Space Invader image on. Then we have SHP score, and that's a shape again. That's the rounded cornered rectangle that we put the score in. We use that within the procedures. Now, the whole point of a global variable is that the values can be shared around the workbook as opposed to creating a variable within a subroutine. Now, most of my designs I tend to have a main entry point to any applications that I build within VBA. So we'll have a look here, and we can see game main, and that will be the entry point. And this is when the user clicks new game button, it will initiate this procedure. Now, everything in green is a comment and is not run by a VBA engine. So the first thing we've got application enable events true. Now, an event is something like a button click, or if you click into select a cell, anything that the user sort of initiates through the keyboard or through the mouse. And it even includes things like opening and closing the workbook, creating a new sheet. So these are events, and the event in this game will be on sheet 1 alien, and the event is button click. That's the event. Let me just go back to there, sheet 1 alien. We can see that the label that we gave it, LBL alien underscore click. Now that underscore click collects the event of a mouse click on that label, and then it runs the code within here. And these pieces of code, they refer to subroutines. So each line here is calling a subroutine. So increase score, decrease size 95, and random move, they're all subroutines, and they've been written elsewhere within the program. So we'll go back to our main module, we'll go back to game main, make sure that events are enabled, and that is that the mouse click is recognized. The first thing we call is a subroutine called counting, and we look for count in. We select count in, and we can see this is a separate subroutine, and this prepares the user for the start of the game and gives an on-screen countdown from 3 to 1. Here we've declared one variable, and that variable is I. I is just generally the term given for an iteration count for some kind of loop. I could say for this one, I as integer, because we're only going to ever need a whole number for this. So an integer is a whole number. So here we say with worksheets alien, if you haven't come across it before, the with block, that gives you sort of a predefined sort of leading to your code. So in this case, we're looking at range AR7 select, and that's hiding the cursor. That hides it behind the option buttons so that it doesn't distract the user in the game. The next thing we go to range counting, and that's the named range that we defined. And the reason I name my ranges with a lowercase n is so that I recognize them in my code quite easily. So in this case, we're saying that our range counting, which we know is a merged field, its font size is going to be 200. A for loop, and the for loop goes from 3 down to 1. To ensure that it can go down minus each time, we give it a step -1. And then we say that the range counting equals I. So I will represent 3 at the start of this loop, the first iteration through this loop. The second iteration, I will represent 2, and then the third and final iteration, the I will represent 1. And this shows 3, 2, 1 to the user. Now, if we were to run this loop on its own, it would go 3, 2, 1 very, very quickly, and we wouldn't be able to see it. So what we need some way of slowing it down. We've got a call to another sub procedure called game timer. I know game timer, that's going to be in MDL random move. If I click in MDL random move, look in the declarations, I can see game timer. Now game timer takes an argument, a double, and that type has a decimal point, so it's not a whole number like an integer. And here we've got its own variable, start time. So the first thing we do is we say start time is equal to XL VBA's timer function, and that collects the time at which we start. Then we run through what's known as a do loop, and that do loop control is at the bottom of it. So we're going to do something, and then we're going to keep doing that something until our criteria is met. Our criteria is the timer as it is now when we look at it, less the start time that we collected earlier, greater than or equal to our delay time. Our delay time is the variable, the attribute that we set for this subfunction. When we called this from our counting, it was game timer space 1. So that 1 represents a 1 second delay. But as we come through it, we collect what the time is now, we go through our loop, and then we say what the time is after that loop, less the time that we started. Is that equal to or greater than the time delay we want? Depending on how fast your computer works, you could have quite a number of iterations through this loop before you actually reach that 1 second delay. There's something that happens every time we go through this loop, and that's the statement do events. And do events means that even though Excel VBA is running, we want that code to be interrupted by an event that happens. And for us, that is the click on the Space Invader graphic. Now, if we didn't have do events within this do loop, this do loop would run and the user would never be able to click the icon because that action would be delayed because Excel is doing something, it's being busy. The do event says even though Excel is busily doing something, it will accept events to interrupt this programming. So that is what this timer is doing here. Now go back to our alien module. To recap, we have a counting 3, 2, 1, but each count that comes in and is shown to the user has a 1 second delay. So it'd be 3, 2, 1, and then nothing, and then the game should start. Go back to our main again. Set alien properties. So we need to reset the game ready to go. So we go to set alien properties. This sets the objects for the alien. Earlier we spoke about the global variables. This is where some of the global variables are allocated a value. So we start off once again with worksheets alien. We apply the global variable SHP alien to shapes LBL alien. So whenever we now use SHP alien, we're always referring to that shape LBL alien. The next one is SHP score, and that refers to the shape score. So whenever we refer to SHP score, that's what we're referring to, is that object. And then we take the game level, what the user selected, easy, medium or hard. That's put in the global variable. So we've updated our global variables. The next thing is to reset the alien to its original size. With the global variable, we have another with block. We're going to say the SHP alien, its height is going to be 30, its width is going to be 40. The next piece of code is our actions based on the user selection of easy, medium and hard. And in this case, we're using a select case statement. In this select case, we're using the global variable int game level. And so int game level will represent an integer. It will be either 1, 2 or 3. And if you notice, we have case 1, 2 or 3. So depending on what int game level is, depends on which piece of code runs. So if the user selects easy, it will go to case 1 and it will run that code increase size 200 height dot width. Then it will ignore case 2, case 3, and then it will end the select statement. When we look at this increase size 200 dot height dot width, that's another subroutine that has its arguments. So it has a number argument, a height argument and a width argument. Now here we can see it says dot height, and dot height represents SHP alien dot height, so that will be 30. And the same again with dot width, it represents SHP alien dot width, so that will be 40. So this will be increase size 200, 30, 40. Now let's go and find this subroutine. Increase size. And we can see increase size, we can see increase as integer, height and width. We haven't defined them with a specific type. So they're variants. We could put anything in these values here and we would be able to use them. We have some local variables. We have dim total values and dim numerator. We do an initial test for increase, which is this value here, to see whether it's 0 or not. And if it's 0, then we'll skip all this code inside the if statement and we'll go straight on to defining what the height is and what the width is. We'll take the height and the width, which we know is 30 and 40, and we'll apply that to the alien heights 30 and 40. Now if there's something in increase, then we do something. So in this case, increase is 200. So then we're going to say total values equals height plus width, numerator is increase divided by total values, and then height is the numerator times by height, and width is the numerator times by width. So we're effectively doing a weighted percentage increase in the size of our alien, and this is how we get the sizing of the alien for easy, medium, and difficult. So once we've applied the values to height and width, we then apply them to SHP alien height, SHP alien width. And the reason we can do that here is because we set SHP alien as a global variable. Now we'll go back to our set alien properties. So we've gone through increased size, and we can see here increased size 0, height and width. So this would bypass the if statement within the increased size coding. And this for us makes reading this code a little bit more easier and less messier, makes it much cleaner to see. Now at the end of this, we also ensure that the alien is visible. So we can see here SHP alien, it's still within the width block, and we can see that we say dot visible equals MSO true. So we're making sure that the user can see the alien. Now if we go back to our main again, so we have set alien properties, we've just had a look at that. Next we've got reset alien score to 0, and now we go to our global variable SHP score, which we set in the set alien properties. We say SHP score text range to text range characters dot text equals 0. The value within that object, that shape, is a text. It's not a number, so it has to be represented as text. The next thing we need to do is we need to show the alien, and we don't always want to show the alien in the same position. We want it to move around so that when a user starts a game, they can't just hover a mouse in one place and select the alien straight away. So what we do is we call a subroutine random movement. Now random movement, that sits under the module random move. So we go over to random move, go to random movement. And this is the bit of the program that moves everything around. One of the things that you need to do before you write the random movement is you need to know where your top left position is and where your bottom right position is. You need to know what the pixels are in that point and what the pixels are in the opposite bottom right corner are. What I've done here is I selected mine by selecting the label and then have it moving the label around to different positions, i.e. I moved it to here, this top left hand corner, and then I recorded its positions from there, and then I did the same and moved it to the bottom right corner and then recorded its positions from the properties, and then I wrote them down on here as a reference. Next thing I've done is I set a load of variables, integer variables, because I'm only going to deal with integers on this. It gives me the left, the right, the top, the bottom, and here we've got left rand and top rand, and these are the random values that will place the alien on the screen. We set the boundaries for the game, which are these values we collected earlier. So int left is 55, int top is 78, int right is 671, and int bottom is 537. The other thing that we do with this is we need to know what the size of the graphic is, because the graphic's going to change when we randomly move it later on in the game. And even at the start of the game, depending on the user selecting easy, medium or difficult, the alien size is going to expand or contract. So what we say is to ensure that the graphic does not overspill our border. The bottom right, or the right hand boundary, let's say, it's a better way of putting it, the right hand boundary of our game area is 671, but we can't put the alien at 671 otherwise, because that will be the left hand side of the alien, the far left. So all the rest of the alien will be outside of the gameplay area. So what we're saying is, however wide it is, take 671 minus the width of the alien, and that is the leftmost position that we can place the alien. And it's the same for the bottom. So we say the lowest position that the alien can be within the gameplay is 537, but depending on its size, we have to take out its height. Gives us the topmost position that we can go towards the bottom. So that's how we calculate that. The next calculation is to generate a random number. What are our left boundaries? So int left, in this case int left is 55 plus a random value times by int right, the furthest right we can go, minus int left plus 1 will give us our bandwidth for left. So our left will be anything from 55 right over to int right, which is 671 minus the alien width, and that's our random banding that we can place a number in there. And we do the same for the top, and we do the same thing there, where we say our banding is between 78 and 537 minus the height of the alien ship. And then below here we apply the random numbers to the shape and place the shape. Now if we go back to our MDL alien and we go to our game page, we've shown the alien earlier in set properties. We set the score to 0, we've placed our alien on the screen, and now we're going to call the game engine, so to speak, and that is time alien move. And this is the code that drives the game. Now let's go to, it's in MDL random move on to that module. Time alien move has already been selected, and we can see here notes are set the behavior of the alien. On each pass the alien reduces size and time before the next move. Now we have two variables, I as integer and move item as double. Now we initially set move time to 3, move into the game loop. So for I equals 1 to 10, so we're going to spawn the alien through this loop 10 times. Move time is move time times 90%, 0.9. So we start off with 3, so it's 3 times 0.9. So whatever value that gives us, that's the move time that we're going to wait until we move the alien. Next call is to the game timer. So we've calculated how much time we want to wait, and we send that time to the game timer. And the game timer, as we saw earlier, that will go through a series of iterations until the allotted time, which in this case is 90% of 3. The next piece of code is decrease size 95. So that's another subroutine. And we need to go over to the alien module, and we'll look for decrease size, and decrease size here, and it takes one argument, which is called percentage, as an integer, so it takes a whole number. So first off we test to see whether we have a value in there. If we don't have a value, if the value is 0 or less, then we don't do anything, we ignore the request. If the value is greater than 0 and less than 100, because we're dealing with the percentage, we want an integer between 0 and 100. Once these conditions have been met, we're going to change the height and the width of the alien as a percentage. So we'll take height times the percentage given here, which is 95, and we'll divide that by 100 to give our percentage value, times height by that, and that's the new height. And the same with width. So that's decreased size. We'll go back to our random move, delayed the random move through the game timer. We've decreased the size of the alien, and now we're going to send a call to random move, and that will calculate our position. And that really is our game. So if I take this off, so we can view all the sub procedures, and we can see we've got time alien move, game timer, random movement, and that's just 3 subroutines within MDL random move. MDL alien, if I now share all the subroutines together. So we start off with the main game entry point. We've got count in, we've got set alien properties, we've got increase size, we have decrease size, we have increased score, and we have end game. Now the two that we haven't dealt with so far is increased score and end game. If we go back to our main, so we can see that once time alien move has completed its routine, then we come back and we call end game. So this is a time-based game. So we go down to end game, and end game, we disable events so the user can no longer click alien icon. We make the alien invisible, so we say visibility is false, and then we show a message to the user with our worksheet alien range AR7. We're hiding the cursor. Range end count in, so that's our merge cells. We're going to say its value is game over, so we're going to show the user a message game over, and we're going to set the font size to 72 because we reset it to 200 earlier. The interruption to this game is the user interaction, and the user interaction comes in the form of a click. So when we're running through the loop and the alien is showing, when we click the alien, we call increase score. So if we pop over to MDL alien, pop it down to increase score. Right, increase score increments the score by 1 and updates the interface. So we have int cur score as an integer, and we have int temp as an integer. This does not take any arguments. So with SHP score, which is a global variable, we say we collect the current score, and because the current score is recorded as text, we need to convert it to an integer so that we can manipulate it, so we can add to it. We get the current score, convert it to an integer, and then we plus 1 to it, and then eventually we put the output from that calculation back into our SHP score as text. So here we take int temp and we convert that to a string, and we place that back in the text box. Go back to our alien. So we've increased the score, decreased size, and then we'll move the alien. So we can see that when we select an alien, we're not going to reduce its size, but we're going to increase the score and move it to another place. The only time the alien will reduce size is when the for loop runs its subroutines. When the game starts, the first iteration of the loop goes around. The alien gets to reduce its size, it gets placed on the screen. If you don't capture the alien by clicking it, then the iteration will go around again and the alien will reduce its size again. The timing with which it then moves again changes. If you click the alien, reduce its size and be respawned in a different place, but the timings won't reduce. But because you interrupted the for loop with this event action, that for loop has to continue. So if, let's say, you interrupted the for loop exactly at its halfway point between its loops, then it still has 50% of the loop to run. So you click the alien, it decreases size, it moves, and then the for loop continues running. So then that's 50% of the allotted time, and it will jump again. So you have an even shorter amount of time to capture that alien. So you click it once, and you've got even less time to capture it again. When the loop goes around naturally, the speed with which you need to click it is the original speed that is calculated. Finally, we have this workbook, and we enable events. And the reason we enable events before the workbook closes, and we can see here workbook before close, and here we say private sub, workbook before close, and we ensure events are turned back on when exiting the workbook. If Excel crashes, then this code may need to be run manually. And what that means is application enable events isn't just for this workbook or that worksheet. This is for your Excel environment. So you want to enable events if you've disabled them. If Excel crashes or something happens with that Excel workbook part the way through the game, and the events were not enabled, enable events that were still equal in force, then that would be the case for every workbook that you opened after that time. So you'd have to go in and you'd have to manually ensure that you enable events. You can quite easily just type this line of code into VBA at any point and run it, and then you'd be fine. So that's the alien game. There's not a lot of coding in it, but what it does have is it has events, and if you've not been involved with events before, then this is an introduction to it. The other thing here is global variables, and this introduces the idea of how variables are limited. So here we have global variables here that are available throughout the procedure. And then we have other variables such as in counting, where we have that variable is defined specifically within that procedure. So when that procedure runs, that variable's alive, but once you leave that procedure, then that variable dies. Now there is something else I could probably do at the end of this, and probably do at end game, and actually I think I probably will. So here what I'm going to do is I'm going to copy my global variables, and I'm going to navigate to end game. Now at the end of end game, reset int game level to 0. Now what I'm going to do is, because we set an object value to the SHP alien, we're going to destroy it. We're going to set it to nothing to release that allocation to memory. Now Excel is meant to clear its memory, these object variables, when they're not used. So once we left the workbook, it will be destroyed, or once the programming stopped running, it finished, then they should be cleared. But I'm a bit skeptical of that. I don't always believe that that's the case. What I've done in this case is I'm manually ensuring that we're releasing those allocations to memory. And I'll call this cleanup. And that's the coding behind the game.